Hey everyone, welcome back. We're jumping back into some vector statics problems. We're looking at the statics section of the FE exam. And again, we're looking at how we can use vectors and the relationship between a force vector and a length vector in a cable to really understand some more complex features of that cabling. So here we have an antenna, a tower that's 60 meters in the air. There's a cable suspended from it, and that cable is offset in the x and y direction, and it's on the ground, so its y direction is it's going to have a 0 in its y. And we know that the tension in the cable, according to the problem, is 1,000 newtons, and we want the angle that the cable makes with the ground in the z direction. So let's look at how we can solve this. So first, we have 2 points. We have P2, let's say, and P1. And it's a good idea to probably take P2 as the origin point that we're starting from. So we can say that this is at 0, 60, 0. We'll assume it's the origin in the x and z axis, and it's 60 meters up. So then if we follow that same procedure, P1 is going to be 30 meters to the right, 30 meters in the x direction. It's going to be at 0 in the y because it's on the ground, and it's back 20 meters in the z direction from that tower. So now we have our 2 points, P1 and P2. So we can find our length vector, we'll call it L hat, by taking the points at P2 minus the points at P1. So we could do 0 minus 30i plus 60 minus 0j plus 0 minus negative 20k. And if any of this seems unfamiliar to you, feel free to look back at some of the other vector videos. And we're going to get our length vector here, so it'll be negative 30i plus 60j plus 20k, right? We're taking a negative of a negative, so this is going to give you plus 20k. So now we have our length vector. As always, we can take the magnitude of that. We will do the square root of the sum of the squares. And that's going to come out to 70 meters. So we have a length of 70 meters there. So now we know about the length, and we have a vector of the length. We're going to want our unit vector. And remember the unit vector is our vector divided by its own magnitude. So it's going to be negative 30i plus 60j plus 20k each over 70. So our unit vector is going to be negative 30 divided by 70, so that's about negative 0.43 plus 60 divided by 70, so that's going to give us around positive 0.86 j. And then our k value, 20 divided by 70, is going to give us about positive 0.29 k. So now we have a unit vector, and we found this, remember, using the cable length vector. But this unit vector has a magnitude of 1, and it's the unit vector for both the cable length and the cable force. So now, if we want to get our force vector back, we can just take our force magnitude and multiply it by our lambda, right? We're just doing what we did up here, but in the reverse. So do we know the magnitude of our force? Well, we do know the magnitude of our force. We were told it was 1,000 newtons. So we have 1,000 newtons times our unit vector. And again, we're doing the same thing we just did before in reverse now. So 1,000 times negative 0.43, we move it over 3 times. So we're going to get negative 430 I, 860j, and 290k. Excellent. So now we have the vector defining our force going through the cable in space. Now we want to find the angle in the z direction that this force makes. So I'll call this theta z, and I'll write it up here. There's a lot of ways to find this. You could use a lot of different geometric tricks, but really this is the cosine angle, and it equals the z component of the force over the force itself. So if we think of cosines, right, think of SO, CA, TOA, it's the adjacent over the hypotenuse. The hypotenuse is the full magnitude along this vector. The adjacent is just the z component of this vector. So we're concerned with f of z and the magnitude of f itself. The magnitude of f itself we know is 1,000 newtons. F of z is just the k component, the z component, so 290. So again, we get back to 0.29. So cosine of theta z is 0.29, so we'll take the arc cosine of 0.29 to get our angle back. And theta z will be at around 73 degrees. Now the nice thing about this approach is that because you're in three-dimensional space, you can actually get all of the angles based on the cosine value. So in this case, they're asking about theta z. If they wanted theta x, it would be the same thing. It would be cosine theta x equals f of x over f. And if they wanted it in the y, it would be cosine theta y equals f of y over f. So we can follow the same approach for all of these different terms. Enjoying these videos? Follow the links in the description below to find out how you could reach out for personal tutoring, like and subscribe to get notified when new videos drop, and comment with suggestions for future topics.